let us see how to draw ILD for support reactions, influence line diagram for support reactions. Consider a simply supported beam okay. Let this support be A, this is B. Okay. So ILD meaning we have learnt definition that when one unit load travels or moves from A to B or from B to A, how the various functions like support reactions, shear force or bending moment will change. So it will be represented in the form of a diagram that we call it as influence line diagram. Okay. So now let us plot influence line diagram for these reactions. Reaction at A, reaction at B. Okay. So let the unit load is traveling from A to B. While it is traveling, when you take a picture of it, let us say the unit load is at a distance of x, okay, from A. Okay. So now from the equilibrium you are able to solve the support reactions, which is RA and RB values. So let you have solved the support reactions. So RA you got RA as L minus X by L, and you got RB as X by L. Okay. So I hope you can perform these calculations, RA and RB, from your prior knowledge. Okay. So to plot ILD for RA, when x is equal to 0 means when unit load is at point A, what will be reaction at A value? It will be 1. When you substitute x is equal to 0 here, okay, you will be getting 1. Similarly, when load moves from A to B, when x is equal to L, reaction at A will become 0. When you substitute x is equal to L in this equation, so it will be RA 0. And between 0 and L, while unit load is traveling, the values of reaction at A change from 1 to 0. Okay. So whether the variation or reduction from 1 to 0 is in the pattern of straight line or parabolic or cubic, that will be known by looking at this equation. So reaction at A values are following proportionality with x. So by observing that RA is proportional to x, so we will be able to assess the pattern how the RA values should follow from A to B. So now I am plotting the reference line, okay, that means x-axis, okay. So at A, the reaction at A is 1, so I am plotting RA value here, which is 1. When x is equal to L, this point, RA is equal to 0. So I am plotting both the values 1 and 0. So I plotted 1, plotted 0. Now from this end A to B, the values shall follow straight line pattern. Okay. So join this point and this point by a straight line. So this is ILD for reaction at A. So what does this mean? That reaction at A will be maximum when unit load is exactly on the support A. When load moves away from support A, the reaction at A is going to reduce. Okay, and when load reach B, the reaction at A will be 0. Okay, that is how we can assess the nature of the diagram. Okay, right. Similarly, plotting RB values. So this is a reference line. Now coming to the values, when x is 0 means when unit load is at A, a reaction at B is equal to 0. Okay, when load is on the support A, reaction at B will be 0 because x is equal to 0. When load reach support B, reaction at B will become 1 when you substitute x is equal to L. Okay, so the reaction at B is varying from 0 to 1. Okay, and by observation you can see that RB is proportional to x, which means it is also following the straight line pattern. So the reaction at B is 0 when load is here. Okay, so on x-axis you shall plot the position of load. So position of load is at A, value of RB is 0. When position of load is B, RB value is 1. Okay, now join these 2 points by straight line. Okay, so now this is the ILD for reaction at B. Okay, now coming to the sign convention, these values are positive, these values are negative according to the sign convention that you are following. Like left upward force is positive, right downward is also positive. Okay, so with these notations we can say this is positive, this is negative force. Okay, so this is how you plot the influence line diagram for support reactions. And what you can infer from this ILD for RB, you can see that reaction at B values are varying from 0 to 1. When load is at A, the reaction at B is 0. Means when load is exactly on support A, reaction at B will be 0. When load reach B exactly over the support, then the RB value will become 1. Okay, so for maximum support reaction at B, the load shall be placed exactly over the support B. Similarly, for maximum reaction at A, the load shall be placed exactly over support A. Okay, so this is what you can read from these 2 diagrams. Okay, so the usage of the ILDs we will be talking later. Okay, thank you.